Hello guys, this is NP Chan. Welcome to my mathematics class. Today's topic is very important long questions of binomial theorem. Uh, Before this, I made one video which was based on very important short questions, right? Today I'm making the very important long questions of binomial theorem. These are really very important questions and very important from the examination point of view. Let's start the question first, right? How to do? First question is show that the middle term of the expansion of this is this one, and this is this one. Both are of the same type of question. If I do next, also you can do. Otherwise, okay, let's see. I may tell you also. So I'm going to tell you the proof of first, okay, question. First part. So see, total number of in the expansion, you may start like this way. In the expansion of 1 plus x raised to power 2n, total number of terms, right? Total number of terms is equal to, I have represented by capital N, total number of terms is equal to here 2n power plus 1. So 2n is already even number. If we add 1 in even number, you get odd number, right? So which is odd, okay. So odd, okay, therefore there is only one, okay. As I told you in one first video, therefore there is only one middle term. Only one middle term. Middle term. Now let's see the middle term. Middle term is equal to formula T of n plus 1 over 2. N plus 1 over 2, or T n. What is your n? N means 2n plus 1 by 2. You will get here T 2n plus this formula I have applied, okay? Or 2n plus 2 over 2. You will get here T of n plus 1. Okay, everybody, up to here, which is in the form of TR plus 1. Alright, here, okay, and will work as R. So let's write down here a general term, you know, right? C of power is 2n comma n, because R is your n, into 1 or 2 n minus n. Just formality I'm going to complete. X raised to power n. So actually, okay, general term is this one, TR plus 1 in the expansion of a plus x raised to power n. We have general term C of n comma r, a raised to power n minus r, x raised to power. This is the general term. I have used, okay, this one formula to find out the value of t of n plus 1, okay, in this expansion. Alright. Now, after this, you will get C of 2n comma n. 1 raised to power n means 1. X raised to power n is x. So 1 I'm not writing here again. So this is the middle term. Now, but actually, okay, we want to prove, okay, in this form. This is also the middle term of this expansion. Now we have to expand, okay. We have to find out the value of C of 2n comma n, okay. We have to expand in this form. Alright, so let's try to find out, no problem. Is equal to any space. So that's why I'm writing here. So this one is 2n factorial upon 2n minus n factorial x raised to power n. Not so difficult, it's easy, alright. So I'm going to tell you in a very easy way. Just stay with this video. Here 2n factorial over n factorial x raised to power n. Okay. And then you need to expand to n factorial. As we know, the n factorial is equal to n minus 1, n minus 2, n minus 3, so on dot 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 3 to 1. Here also you are going to get in the same way. 2n factorial we can write on 2n or 2n minus 1, 2n minus 2, 2n minus 3, alright, and dot dot dot, and you may write on 3 2 1. Okay, whole upon, here we have n factorial, and into x raised to power n. Now I need space, okay, I'm going to erase this part. I think you understood how to write down, right? So clear here, no problem, right? I have just applied the factorial. I need, okay, after this. So see, so I'm taking you here. After this, you have to collect, okay, even and odd, okay, even in one bracket, odd in another bracket, okay. See, even 2n like this way, or 2n minus 4, 2n minus, okay, or 2n minus, okay, 2n minus 2, okay, 2n minus, okay, 4, you may write down, because next you will have 2n minus 4, and dot dot dot, finally, okay, 4 2, because here I have not written, so 3 before 3 there is a 4, and here 2 I have written. Here 2n minus 3, after this you will have 2n minus 4, you may write down, okay, no problem here. And now just collect the odd you have from here 2n minus 1, and then into 2n minus 3, and dot dot dot, you will write down 5 3, because okay, you will get 5 4, okay, and 3 1, okay, uh, upon here n factorial into n factorial, here times x, here times, okay, x raised to power n also, right? So let me get the space for that. 5 into 3 into 1, okay, here in this bracket, and x raised to power and this one. Alright, this step is clear. Now I think you have no problem. After this is equal to, now you know, right, 2n minus 2, 2n minus 2, 2, 2. Here also 2, here also 2 in multiplication. 2 is also here, right, in multiplication. So we can write 2 into n, okay, and here 2 bracket n minus 1, and again 2 into n minus 2, okay, dot dot, here 2 into 2, into 2 into 1, I'm writing like this, right? So look at here 2 2 2 2, right? And here also you have a 2. So you know, right, okay, we have here n terms, right? If 2 times 2, then 2 raised to power 2, you may write down. So this here, as I told you, okay, we have n terms, okay. If we write, okay, 2 times 2, then you can write down 2 raised to power 2. If we write down 2 times 2 times 2, how many times we have? 1 2 3 4, we can write down 2 raised to power 4. If we write down, okay, up to n terms, then you can write 2 raised to power n. Alright, so I think you understood. Now here, okay, you have not to do the, just reverse, okay, write down in reverse way. Just I will start to write down 1 into 3 into 5, dot dot dot, 2 and minus 1, and okay, so last one I've written, okay, I will drop, because of space you can also drop, it doesn't matter. Okay, whole upon here n factorial into n factorial. Alright, so here no problem. So 2 2 2, okay, we can write on 2 raised to power n, and inside the, okay, inside the bracket you may write down, okay, n minus 1 and minus 2, dot dot dot, 2, 1. Alright. So this is the expansion of n factorial. And this one is 1, 3, 5, dot, dot, and 2n minus 1 whole upon n factorial into n factorial times x raised to power n. Now I'm going to write down here 2 raised to power n, and this is also in factorial, and here 1, 3, 5, dot, 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 2n minus 1 whole upon n factorial times x raised to power n. N factorial get cancelled. Finally you will have 1, okay, dot 3, dot 5, dot, dot, and you can write down, okay, into 2n minus 1 into, okay, here n factorial. So this is okay. This means there are so many terms. And factorial cancel, and here we can write down 2 raised to power n x raised to power n. This is a final, right? Final line of this question. Like this way we can prove only this thing, okay, which was to be proved, okay, we got it, right? We got, okay, how to find out, okay. Now I don't think you have a problem. Now you can prove this question. Listen to me very carefully. This is the one of the important questions in binomial theorem, right? So now I'm going to this one, what to do here, right? Same method. I will apply here also same method, exactly the same method, right? Very easy. Now if I do the second one, so you will be more clear about this type of question. Let's move into the second part of the first question. Solution. In the expansion of, you can write on like this way, in the expansion of, here also we need to find out the middle term. In the expansion of 1, sorry, here we have x minus 1 upon x raised to power 2n, right? 2n, the total number of terms. The total number of terms. Okay, here bracket total number of terms is equal to, because here 2n, so 2n plus 1. To find out the total number of terms, we do n plus 1, power of binomial plus 1. Okay, which is odd. Which is odd. Which is odd. So which is odd? There is, this means, okay, there is only 1. So therefore, if our total number of terms is odd, then there will be only 1, okay. There is only 1. Therefore, there is only 1 middle term. Therefore, there is only 1 middle term. Now, let's find out the middle term. Middle term, as we have applied, okay, formula in first case, same formula we have to use n plus 1 by 2 is equal to t of 2 n plus 1 by 2. So I think, okay, same we will get, okay, n plus 1, and we can use c of power is your 2n or 2n comma n, this r, and then, okay, a is your x raised to power 2n minus r, means n minus r, r is your n, into minus 1 upon x raised to power n. This is, okay, formula from general term, as I told you earlier in earlier question also. Okay, now I think you understood how to write down this one. Alright, so once again let me tell you, n a plus x raised to power n tr plus 1, this formula we use, which is also called your general term, c of n comma r N is this one, R is this one, because this one is also in this form, T of R plus 1, right? So T R plus 1, and A N minus R, A means first term and second term raised to power R. We use this one to write down this line. All right, now no problem you have, right? So is equal to, now you can 2n factorial upon n factorial times n factorial, because 2n minus n factorial, x raised to power n, your minus 1 raised to power n, upon, you can write down here x raised to power n. See very carefully, okay? This video may be lengthy but very useful to you, right? I'm going to tell you in details, okay? Here cancel, they can be cancelled, and here you will get, okay, 2n factorial over n factorial minus 1 raised to power n. Alright, now we need to expand this one. This is here 2n. The same method, okay, exactly the same method you have to use, okay, to expand this 2n and 2n minus 1, 2n minus 2, dot dot, and here you may write down 5, 3, 2, 1. Okay, sorry, 4 I forgot to write down, and 4, 3, 2, 1 you may write down into over here into, okay, you may write down like this way, into in, and dot dot, it is, or you may write down, okay, into this one, 1 2 3 dot, clear. uh, and over n factorial, here minus 1 raised to power n. Alright, now you have a problem. Just, okay, what is the numerator? From where we got numerator, just we have expanded to n factorial, right? You can just experience the genuine class of mathematics. You just go through each and every second of the video, okay? Now I'm going to write down here because lack of space here. Now, okay, 2n. So again I will collect even terms, even number, even one in one bracket and odd numbers in another bracket, right? So see 2n or 2n or 2n minus 2, okay, and here you will get 2n minus 4. Actually I have not written, okay, dot and then 4 and 2, okay, these are even numbers, and in another bracket you may collect odd means 2 and minus 1 dot simply, okay, 5 3 5 into 3 into 1, okay, whole upon n factorial into n factorial, okay, and here x not, okay, minus 1 raised to power n. So up to here, clear everybody, is equal to, now here you know, right, in, okay, in first question as I told you, 2 into n, you may write it like this way, 2 into 2 and minus 1 into 2 and minus 2, okay, dot dot, and 2 into 2, and again, okay, 2 into 1 also you may write down, right? Okay, here is just write down in reverse way, 1 into 3 into 5, or dot dot dot, into 2n, or 2n minus 1 whole upon n factorial into n factorial into here times minus 1 raised to power n. So each and every line I'm going to tell you in details, right? Okay, is equal to, here 2 you may write down, okay, 2 raised to power n, right? 2 raised to power, yeah, if you have a problem you may write down, okay, 2 times 2 times 2 and dot dot 2 n terms, okay. In first question I have not told, okay, here I'm going to tell you 2 times 2 times 2, okay, and then here you will get, okay, n and minus 1 and minus 2 dot dot dot, and then okay you write on 2 into 1, and here okay same 1 into 3 dot dot, and 2 and minus 1 whole upon n factorial into n factorial. Okay everybody, here no problem, here minus 1 raised to power n, minus 1, okay, lack of space, minus 1 here, this is a minus 1, minus 1 raised to power n, okay, right? uh, is equal to, now this is okay, 2 times 2 times 2 times 2 n terms, you will write down 2 raised to power n, here this n minus 1 and minus 2 dot dot, this is the expansion of n factorial. Instead of for this you may write down okay n factorial into the same line 1 into 3 into 5 dot dot, and you may write down 2 okay into here into also you may write down minus 1 upon n factorial into n factorial into minus 1 raised to power n. So I think you are enjoying, you are understanding each and every line of this, right? Okay, now they can be cancelled because they are equal. And now we can write down finally 1 into 3 into 5, okay, into dot dot, okay, into 2 and minus 1, right, upon n factorial 2n. So listen to me here, 2n into minus 1 raised to power n, because they are both have the same power. By using okay law of indices we can write down it okay like this way, and this becomes okay minus 2 raised to power n. So into minus 2 raised to power n by using the law of indices. So we have proved okay this is this is the line okay to be proved. All right, so now you understood okay how to prove, how to find out the immediate terms of in this expansion and of this expansion, right? So these two questions are also very important, right? Here each and every questions are important, okay? These two are frequently we can see in a final exam, right? I also think now you have a problem. If you have a problem, you have way to express your problems, okay? Now let's see into question number 2. 2 is also very important question, okay? Very interesting long question. Well, this first one done, so I'm going to erase from the board because I need space. Question number 2. So I'm going to start with this one. Here, if the three conjugative coefficients, conjugative coefficients in the expansion of this be 165, 330 and 462, find the value of n. We want to sometimes even get okay, find the value of r and n to find out okay here n, only n. So see okay, you can suppose a solution, let okay c of n comma minus 1 comma c of ncr, or you may so ncr or c of n comma okay, and c of n comma r plus 1 or b the three conjugative coefficients in the expansion of 1 plus x raised to power n. Alright, and then after this, then we can write down okay c of n comma of minus 1 is equal to 165, because they are okay conjugative coefficients. C of nr is equal to 330, and your c of right here coefficient, let me write down okay one word, this with three conjugative coefficients in the expansion. Okay, conjugative written, okay, then no expansion, then okay, alright, no need to write on respectively. Okay, 165 and C and comma 330, and then okay, they are in conjugative, this here also in conjugative, then uh, this equal to 165, this represents okay this one, and this will be equal to this, right? And the C of n comma r plus 1 is equal to 462. Let's say this one is the first, second, and third. Okay, so how to find out the values of n? So very simple. Okay, we have to okay just divide okay second. See, a very simple method. Dividing second by first we get. Listen to me, right? C of n comma r over C of n comma r minus 1 is equal to 330 over 165. And here you may do n factorial over and minus r factorial. See very carefully this line. And times, right? And times, you know, right? This will be in okay, denominator n factorial, right? Over. So I'm going to, that will go later, okay, here. So, okay, here I'm going to write directly n factorial n minus r plus 1 factorial, and whatever I need to write down here, so I am okay shifting in numerator, alright, because that will go in a numerator later. So I'm skipping one step. Okay, n factorial over n minus r plus 1 factorial and r minus 1 factorial is equal to here 2. 5 to the 10, 16 to the 32, 33, right? So here you will get 10. And C going to be cancelled. Okay, now listen to me here. N minus r factorial, n minus r plus 1 factorial, here r factorial, here r minus 1 factorial. See very carefully, n minus r plus 1 factorial. Now here, okay, see these two are of same, means okay, in the same expansion, they will come. Here n minus r plus 1, n minus r. So this one is greater. So greater one you have to expand, right? R factorial and r minus r 1 factorial. So r factorial is greater 1. So you need to expand r factorial. Okay. So expand. See, let's start to expand. Okay. You will n minus r plus 1, and then you will get n minus r factorial. Okay, because okay, expand, you can stop it just like 10 factorial. We can write 10 factorial if we need. Okay, 10 factorial means is equal to 10 times 9 factorial. If we need okay up to 9 factorial, we can expand up to this line, this number, right? Here also the same thing I have done. Okay, we have expanded this n minus r plus 1 into n minus r factorial, and we are not going to expand r minus 1 factorial because r factorial is greater 1. So okay, n minus r factorial, and r factorial you can write r minus 1 factorial, okay, is equal to 2. Very interesting. Not so difficult. Okay, cancelled, and here okay, cancelled, gone. Okay, now we are free from factorial. So we can write down okay, n minus r plus 1 over r is equal to 2. Now let's simplify. N minus r plus 1 is equal to 2r, or you will get n plus 1 is equal to 3r, or okay, r is equal to n plus 1 by 3. Let's suppose okay 4. We have got the value of r. Here r is, in terms of n, we have got r is equal to n plus 1 by 3. Okay. Now I will apply okay here in last. Okay, this time okay I divided okay second by first. Now I will divide okay third by second. Okay. So I need okay space. Okay, so I'm going to erase. All right. I'm going to okay divide. Now see. Again you may write down. Dividing 3 by second, we get C of n comma r plus 1 over C of n comma r is equal to 462 by 330. Right? I need space, so I'm going to. Okay. Only I need this result. Mm-mm. Or, so here, n factorial over n minus r minus 1 factorial, r plus 1 factorial times n factorial over n minus r factorial, r factorial. Right? Now I think you understood. Is equal to 330 and 462. Okay, I think they goes by so 11. So 330 462 by 330. I think it goes by 11. 11 threes are 30 and 462 here 11. 11 fours are 42. 2. Okay, 42, right? 42 again. Okay, it goes okay 7 5 7 sixes. Okay, here we are going to get okay 7 by 5. All right, so you can check your this calculation. So 7 upon 5, this upon this, okay, 7 upon 5, or we can cancel because they are going to be cancelled. Now look at here, okay, which one we have to expand, okay, n minus r minus 1, n minus r. So this one is greater one. So let's expand this one here, r plus 1 factorial, r factorial. So this one is okay, greater one. All right. So n minus r and here n minus r minus 1 factorial, r factorial over n minus r minus 1 factorial, here factorial of r plus 1. So let's expand this, r plus 1 and into r factorial, 7 upon 5. Now okay, so let's remove. All right, and let's remove this one. Now factorial gone. We have okay n 5 or n minus r. So I have a cross multiplied also 7 into r plus 1. Let's multiply here. Okay, 5n minus 5r is equal to 7r plus 7, or you can, because we want to find out, okay, n value of n, right? So 5n is equal to 12r plus 7, or 5n is equal to, let's put the value of r. So what is the r? Okay, your n plus 1 by 3 plus 7, or you will get here 5n is equal to 4n plus 1 plus 7, or 5n is equal to 4n plus 4 plus 7, and you will get okay 5n minus 4n n is equal to 11. So therefore value of n is 11. So this is your answer, right? 11. Alright, so easy, not so difficult, but little bit lengthy, alright. But important question, one of the important questions in binomial, how to find out the value of n, right? So I don't so think now you have a problem, right? I have done here each and every line of this question properly, right? So definitely you will enjoy, right? And you will understand, and definitely you will be satisfied, okay, by this video, okay? Now, last question, okay, we are now in the last question of this video. Just I will tell you the hint, okay, how to prove this question, alright. Here, okay, if the four conjugative coefficients in the expansion of this be A1, A2, A3 and A4, then prove that this plus this plus this. Not so difficult, but little bit lengthy, alright. So here you can suppose, okay, question number 3, solution. Let, you can write down, okay, NCR minus 1, NCR, NCR plus 1 and NCR plus 2, because for 1, 2, 3, 4 and be the 4 this type of symbols also we can use. Conjugative coefficients, right? Coefficients in the expansion of 1 plus x raised to power n, or then you can write down here, then okay, NCR minus 1 is equal to A1, 1, NCR is equal to A2, second, NCR plus 1 is equal to A3, third, and your NCR plus 2 is equal to A4, right? 1, 2, 3, 4 I have written. I don't so think you have a problem here, right? Up to here, all right. Now okay, we will find value of this one, value of this one, and value of this one. Then you can take left hand side is equal to right hand side. I will tell you the easy way how to find out the value of this. Thereafter you can find out easily value of this and this, right? Remaining things you can do yourself. Now okay, A1 upon A1 plus A2, how do you find out, right? So value of this, if you know how to find out the value of this, easily you can find value of this one and this one, alright? And thereafter you can prove, okay, left hand side is equal to right hand side by taking left hand side, right? A1, what is the A1 here? NCR minus 1 over here NCR minus 1 and plus NCR. Okay, now you have no problem. So is equal to still don't, okay, and at this stage don't try to think to expand to find to use the formula for this one, no. So another one, okay, individual formula, no. So see, one more formula we will use here, or minus 1 here, and here I am going to write down NCR plus NCR minus 1. This is in formula. So in each and every case you will get in formula, okay, right? So you know, right, we have studied NCR plus C of NR, okay, and okay, minus 1, right? And okay, and comma minus 1 in combination. This is the property of combination. We can write down N plus 1 comma R, right? So we will use this one. So here, so using this formula, we can write down here NCR minus 1 over here you may write down N plus 1 CR, right? N plus 1 CR. This is the property of combinations, right? We have studied, okay, although we have proved also, right? You can see, if you have a problem, you can see BTO properties of some very important properties of combination, right? So using the property I have written this one. And now you can expand, okay, n factorial upon n minus n minus r plus 1 factorial and times, okay, now n plus 1 factorial and now n plus 1 minus r factorial r factorial. Now we have to expand this, right? So I'm going to erase this, and here I will tell you. So after this you may do here n factorial over, now see, you n factorial and n plus 1 factorial, this one is greater one, and r factorial, okay, r factorial, so okay, one thing I missed here also, r factorial, okay, here r minus 1 factorial, r minus 1 factorial here, right? Because n factorial over n minus r plus 1 factorial into r minus 1 factorial. So r factorial, r minus 1 factorial, this one is greater one, and here n minus r plus 1, n minus r plus 1. So already, okay, going to be cancelled, right? So very simple, n factorial, okay, here r minus 1 factorial and times here r into r minus 1 factorial x1 and n plus 1 into n factorial. Okay, cancel, okay, cancel, right? You will have, okay, r upon n plus 1. You can give numbering 5. And similarly, you can find out the value of second term, and then you can find out the value of the term which is on the right hand side of the question. Clear? And thereafter, okay, you can take left hand side and then find out the value of left hand side. You will get the value which equal to, you will get the value which will come equal to the right hand side, right? Similarly, you can find out the second term of the left hand side and then find out the value of the right hand side. Same method you have to use. Exactly, here also you will get in formula. All right, so which one okay formula, which one okay property, I will use okay this one, c of n comma r plus c of n comma r minus 1 is equal to c of n plus 1 comma r, right? This is the property of combinations. All right, so I have written here. If you have a problem, and then you can see my video, the properties of combination, some important properties of combination I have proved there also, right? So I think okay you enjoyed. Now you can complete this question, and I have a left okay for you to be done. Okay. uh, Okay, thank you very much for watching this video. Alright, bye bye.